I work as a technical writer at Chrome Developer Relations. I work on topics like performance, privacy and security, and recently identity and authentication systems. You can find me online on my website. You can find my docs on web.dev and developer.google.com. On Twitter, I'm BibiDigital, and you can also find my email if you'd like to chat about any of these topics. So, agenda. I want to talk to you about our future without passwords. But before that, sadly, we're going to have to talk about passwords first. And then I'm going to tell you a little bit about passkeys, what they are, how they work. We'll learn about security and how passkeys improve security compared to passwords. I'll tell you a little bit about state of support, and then the anatomy of a passkey system and how you can implement it in your production today. Passwords have been around for a long time, but they're so difficult to remember, and many people don't even bother creating strong passwords. So, passwords. Difficult to remember and not very secure. How many of you had to reset their password in the last month or so? Right? Same. So you're not the only ones. 90% of consumers had to reset their password several times a year. Now, you might be thinking, like, password managers do help here. Right? I don't know, which password manager are you using? So password managers really do help. They can autofill your password. They can save your credentials. They make sign-in experience faster. However, not everyone uses password managers. Research has been conducted, and I wasn't really joking. About 9% of people saves their passwords in a local file. Then some 40% just tries to remember them. Another 30% uses password managers. And then a staggering, like, 18% of people actually write them down on paper. And managing passwords aside, they're just not very secure. So passwords are one of the most common entry points for attackers. According to Microsoft Azure data, there's 921 password attacks every second, and they're nearly doubling in frequency in the last 12 months. Another issue with passwords is that they're susceptible to phishing attacks, which trick users into revealing sensitive information. So no matter how many capital letters or special characters a string has, a deceptive sign-in page can trick users into entering their password on it. And phishing scams have lately been on the rise, doubling, I think, maybe increasing 12 times since 2016. Now, let's see. You might be thinking, okay, two-factor authentication, right? Yes, it does help, but it adds extra steps for users, and it costs you money. So that's why today, I want to tell you about a new and a better way to sign in on the web with Passkeys. Passkeys are a simple and secure cross-device authentication technology that enables you to sign in to online accounts, to create online accounts and sign into them without using a password. So a passkey is a digital credential. It's tied to a user account or an application. So on sites and apps that implement passkeys, the browser or operating system will show user a prompt. Then the operating system allows you to authenticate with however you unlock your screen. It could be facial recognition, it could be a fingerprint, PIN, or a pattern. Once you create a passkey, the next time you're signing in, you sign in the same way by using your screen lock. Passkeys are developed by FIDO Alliance. This is an industry body that aims to standardize ways for users to authenticate without relying on passwords. A lot of big companies are part of FIDO Alliance, including Google, Apple, and Microsoft. So this thing is a web standard. And FIDO Alliance has also been conducting research. So they have recently learned that about 58% of users abandon shopping carts because of difficulty of managing passwords. So improving sign-in experience here can also help really impact your business. Passkeys, on the other side, are much simpler. So users don't have to type in anything. They can sign in by using the account selector. They can also they rely on screen lock methods, which support biometrics, so facial recognition, fingerprint, but also PIN or a pattern. And they are very convenient. You can seamlessly switch between devices because passkeys can be synchronized with your password manager. Passkeys have many benefits. For your business, they allow higher login success rates, reduced drop-off rates, and they also reduce the cost of having separate two-factor authentication systems. Google has also been conducting some research, and we have found that users can sign in with passkeys almost twice as fast than with passwords. So on average, users can take in our research, about 14 seconds to sign with passkeys compared to 30 seconds to sign in with a password. Now, you might be wondering who's using passkeys. Well, a lot of companies have already implemented. So we have PayPal, Kayak, Yahoo Japan, Shopify. This is a really big e-commerce solution which has over 2 million users online. And passkeys are also coming to many other sites and apps, such as Amazon, Intuit, and password managers are catching up to, like Dashlane and 1Password. And there's another big company that has recently implemented passkeys, which is Google. So in May 2023, Google accounts have started supporting passkeys. And let's see, can we have a show of hands? How many of you has used the passkey to sign in somewhere? Okay, amazing. That's pretty good, but still a minority of this room. Now, can we have a show of hands? Like, how many of you has a Google account or a Gmail that you use for something? Okay, so for all of you, if you'd like to try a passkey, you can check out this link. It will take you directly to your account settings in your Google account, and it will allow you to create a passkey and sign into it. I'm going to give you a second. Just take a picture and maybe try it out later, but also it's pretty fast. You could do it while I take a sip of water. So I can also show you a demo right now. Let's say I have a bank, and I use their site on my phone. And let's say this bank is really on top of their game. They've just implemented passkeys. Now, when I sign into my bank site, let's see. They offer me to create a passkey. Now, the OS prompts me. I use my screen lock to confirm that I want to create a passkey. And that's it. Passkey created on the device. Now, the next time I want to sign in, I will automatically get the option to sign in with a passkey. As I focus on the account name, I get the options of available credentials. I touch my fingerprint for my screen lock, and I'm signed in. Now, let's talk about security, because this is a major advantage of passkeys over passwords. Passkeys significantly reduce the risk of data breaches, and they also prevent phishing. So passkeys are based on public key cryptography. A passkey is a private key that's stored on your device, and the matching public key is stored on the server. Now, because no secret is stored on the server, passkeys are safer because server breaches are not as big of a risk. The attackers who acquire the public key can't really use it to authenticate. The passkey also includes metadata, such as username and the server domain, so that apps and sites know which passkey to ask for. And another important thing to note is that users' biometric information never leaves the device. So here's just a little diagram of how that works. We have a private key, which is our passkey, on the device. Public key stored on the server. When the user authenticates on the device, he's not sending the private key to the server. He's just sending a message to the server saying, this user has the correct passkey, and then the server lets you log in. And the second benefit of passkeys is that they are phishing resistant. So each passkey is unique to the service it's created on, and it's bound to that service. So if you go on a little sketchy website that maybe looks like your bank, there's no password to type in. There's nothing that the attacker can acquire. Your passkey is unique to your service, and it's stored securely on your device. So if this all sounds cool, you might be wondering, is this available? Where is it supported? Well, actually, it's supported almost everywhere. So it's supported across all major platforms and browsers. We have it since Chrome 108 and Edge 108, since Safari 16. So we have it on Google, we have it on Apple platforms, on Windows, and the support is coming to Firefox in 2023. Now, I talked a little bit about seamless device switch and account synchronization. So here's the thing. Your passkey is able to travel and seamlessly switch between devices in the same ecosystem. So if I use my Android phone, my passkey will be backed up by Google Password Manager. And when I get my new Android phone, if I'm logged into the same Google account, I can synchronize my passkeys. Same thing for Apple, except Apple uses Keychain. However, you can't seamlessly switch between your Android phone and, for example, Safari on Mac. But there is a way to make it work, because passkeys can travel across ecosystems with the hybrid protocol. So I can use a passkey that I have saved on my Android phone to sign in on friend's macOS computer by scanning a QR code. Now, I'm going to show you how that works. If we go back to my fictional bank website, and let's say I have the passkey on my Android phone, and now I'm going to do some heavy banking. I want to use it on my laptop. I open the site on Safari on macOS, and I have no passkey on that device. I have a passkey on my Android phone, which is to your left. If we could play the video. And if not, I'm going to narrate what happens, and you can find me later. OK, cool. So I'm going to click the button, sign in with the passkey on the website. No passkey found, but it lets me use a different device. It gives me a QR code that I'm going to scan with the camera from my phone. Now, the two devices must connect, and once the connection is established, my phone prompts me to use the passkey that I've saved on the phone. I'm authenticated on my phone, and it allows me to sign in on the website on my computer. So in this case, this is a cross-device and cross-operating system mechanism. It's standardized under FIDO, and it's available in Chrome, Safari, and other browsers to follow. And another cool thing is there's no additional implementation steps needed from developers to enable this experience. Now, what about devices and platforms that do not support passkeys? Well, like any new technology, it's going to take a while for everyone to catch up, so you should still keep your password-based systems and use this as progressive enhancement while device support increases. Okay. Now, I'm going to quickly go over some terms and show you what's the anatomy of a passkey system. We're a bit short of time, so I might not manage to cover everything, but here's an attempt. So a passkey, a really important term, is a relying party. So this handles passkey issuance and authentication. So the relying party is practically your site, and you have to run a client, which will create the passkey, and you have to run a server, which will verify the stored credentials. Then the authenticator is the device that the user has that actually creates and verifies passkeys. And then the password manager, or really, technically, it's not really a password manager. Now that we have passkeys, we can call it a credential manager. It stores and synchronizes your passkeys. So on the web, you can see it on the diagram. We have these 4 key components. You need to have a browser running JavaScript. You need to have your authenticator device. And then the relying party must have a front end and the back end. So private key, the passkey stored on the authenticator. It sends a signature to the server, which holds the public key. And if they're matched, you're signed in. Okay, now a quick run through of how to create a new passkey with WebAuthn. This is the JavaScript API that supports passkeys. So to create a passkey, you need to call navigator credentials create. This is just a sample code, and it shows you a few key parameters that you should provide. So you have the challenge, which is, let's start with the relying party ID. Like I said, that's your domain, which passkey is associated with, and this is what prevents phishing. So once passkey is created, you're setting your domain example.com, and the user can only sign in on the example.com. Now we have the username and the user ID, and this is what's used to display the account selector. And then setting, whoops. Okay, let's go back. Require resident key true is what allows users to create an account without selecting the username. And here's what needs to happen for the user to sign in with the passkey on your front end. You call navigator credentials get. And then challenge, which is generated on the server, prevents replay attacks. And mediation conditional allows authentication to only happen if the credential is found on the device. And this is my favorite part. So this is what you can do in your form autofill to enable signing in with passkeys. When you have your input for a username, just like you add the autocomplete attribute for passwords, you can also add the autocomplete attribute for passkeys. So you add username, WebAuthn to autocomplete, and this enables the browser to actually use the autofill functionality. And when users focus on the username field, they will be offered passkeys for autofill, just like with passwords. So for a step-by-step guide on how to implement this, you can check out this code lab on developers.google.com. I'm going to give you a moment to scan it. But I'm also going to say, you don't really have to go step by step, because there are many libraries that have already implemented a lot of starter code that enables you to add passkeys to your app. You can find the curated list on awesome WebAuthn. This is the GitHub repo. So for your front end, you have starter code for Ruby, for TypeScript, for all sorts of libraries. And I didn't really go into server-side implementation, but there are also libraries that help you start with Java and PHP. OK, I think I'm running on time, so let's do a little recap. So passkeys allow you to sign in without typing passwords. You can use the account selector. The mechanism they work on is by using a screen lock, so users can sign in with any screen lock method that they unlock their phone with. So fingerprint, facial recognition, PIN, or a pattern. And because of password manager synchronization, you can seamlessly switch devices in the same ecosystem, but also with the QR flow, you can use a passkey from one device to sign in on a different device that doesn't have it. They are based on public key cryptography, which really reduces their susceptibility to data breaches. And they're also resistant to phishing because each passkey is unique to the service it's created on. And the support is widely available today. So if you run, if your app or a service has any form of authentication, you can start looking into passkeys and improving your user's experience. To learn more about passkeys, we have a lot of documentation available on developers.google.com. You can access it on this link. And I really think we are well on the way to a passwordless future. And if you decide to implement passkeys today, you are protecting your users, you are improving your service, and ultimately, you're making your users happy. Thank you all for your attention. I'm going to add all the links to the resources to Vito, and I'll be around to chat about any of these topics. Thanks.